Friends, today I am now restarting our second part on tensor video. So in the first part I have introduced you with the basic concept of tensor. Okay, now today I am going into the deeper details of tensor. So for going into the deeper details of tensor, first of all you have to know one thing, that is Einstein summation. Einstein summation, what is that? And Kronecker delta. Today I will discuss about deeper details in the tensor. So before that I am introducing you Einstein summation of Kronecker delta. What is that? So let's discuss. So whenever we are discussing Kronecker delta, before discussing Kronecker delta, we have to know tensor. For the time being, know that tensor has two parts. One is covariant tensor, another is contravariant tensor. So before going to the Kronecker delta part, I am discussing that tensor has two types. One is covariant tensor, another is contravariant tensor. So before discussing covariant, contravariant, for the timing only when we are denoting the Kronecker delta, and if we denote the index at its power, then it is contravariant Kronecker delta. Contravariant Kronecker delta. But if we denote Einstein's summation of if we denote the Kronecker delta and its index not at power, at lower portion, that is its prefix, so this is covariant formulation of Kronecker delta. So now we are going to discuss what is the Einstein summation then, and before that the Kronecker delta's general form. So the general form of Kronecker delta is delta I j equals 1 if I equals j, or 0 if I not equals j. So that is the general mixed. It is now it is not contravariant nor covariant. It is mixed tensor formulation of Kronecker delta. So delta ij equals 1 if I equals j, or 0 if I not equals j. Now we are going in deeper details in the Einstein summation. So if we write Kronecker delta in terms of mixed tensor, let me write clearly so that you can understand properly this delta ij. So if we write I equals 1 to dot dot n and j equals 1 to dot dot n, what we are getting? Delta 1 1 plus delta 2 2 plus delta 3 3 plus delta 4 4 plus dot 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 delta nn. So if here I or j equals 1, 2, 3 dot 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 n. So what we can write from the definition of the Kronecker delta? From the definition of Kronecker delta, we can write then delta ij equals 1 plus 1 plus 1 plus dot 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 up to nth term once, 1 up to nth terms. So if we summation 1 up to nth terms, then we are getting total summation equals n. So this is Einstein's summation of mixed tensor of Kronecker delta. So now I am entering into the contravariant tensor. So what is contravariant tensor? Let's discuss contravariant tensor. Okay, contravariant tensor, if the components of a tensor transform between, I am writing by the mathematically. So if the component, a tensor A is a tensor, so its component transform between x, y, z to x bar, y bar, z bar. If its component transform from x, y, z to x bar, y bar, z bar, then the contravariant, this tensor in the contravariant form can be represented as, we can represent this, the contravariant form, a bar j equals del x bar j by del xi ai. So this is tensor of rank 1. This is the tensor of rank 1 in the contravariant formulation. So I have now given you the mathematical definition of contravariant tensor. So what is that? If you transform a tensor A from the coordinate x, y, z to x bar, y bar, z bar, you are getting a bar z equals delta x bar z by delta xi. Always remember, for contravariant tensor, see here, what is the index? Index at its power, in the upper portion. That is the contravariant tensor's indication. So delta x bar j by delta x bar j, this is another coordinate, by delta xi equals ai. So it is a tensor of rank 1. Rank 1 means, for tensor, what is the rank? So you can now ask me, why I am saying tensor of rank 1? Why it is tensor of rank 1? So I am clearing you in this case. When you are denoting a bar z equals del x bar z by del xi into ai. So why this is tensor of rank 1? Because here free index is 1. So where you are getting free index is 1 or free index is 2, where you are getting free index 2, there you can get what? You can get the rank 2. But here for each component the index is 1, number of component. Here j is 1 component free index. So where you are getting the number of free index is 1, that is tensor of rank 1. So in general, what can we call the contravariant tensor of rank P? Now we have discussed only the rank 1 tensor of contravariant formulation. So in general, how can we denote the contravariant tensor of rank P? So a bar mu1 mu2 mu p. I am just writing the general formulation, that's more important. There p number of free index, that means now in contravariant formulation we can denote it del x bar mu1 by del x alpha 1, del x bar mu2, let me write properly, del x bar mu2 by del x alpha 2 dot del x bar mu p del x alpha p. Here it is not fitting total, so I am writing with small. So in general, tensor of rank P can be written as a mu1 mu2 a bar mu1 mu2 mu dot mu p equals del x bar mu1 by del x alpha 1 del x bar mu2 del x alpha 2 dot del x bar mu p del x alpha p into what we can write A of alpha 1 alpha 2 dot dot alpha p. So it is in general here, there's no space is there, that's why I have written this. So this is in general covariant formulation of rank p tensor. So if we write this in contravariant form, so we can write for rank 1 tensor, contravariant form is given by AZ bar. See here, now the index is at below portion, that is at the prefix. So you can write del x bar del x I by del x bar. Observe here x component, that is the component power. The power of the component is not changed, it is on the upper portion. But with respect to x bar, components are changed in the numerator and denominator. In the previous where we are doing contravariant tensor, there we are writing del x bar I by del xj. So in the previous where the contravariant form, we are writing the x bar form where we are writing in the numerator, and now we are writing x bar form in the denominator. So this is contravariant, this is covariant. So if I write both contravariant and covariant side by side, you can easily understand. So I am writing for rank 1 tensor, contravariant form is what? A bar j equals del x bar j by del x I into ai, and covariant tensor is written as A bar j is here, del x I, let me write clearly, A bar j equals del x I by del x bar j into ai. That is, when we are writing now, compare this covariant, and it is covariant and it is contravariant of rank 1 tensor. So when we are writing contravariant tensor, then the index is at upper power portion, and here x bar portion is in the numerator and x is in the denominator. That is when we are converting x to x bar. But when we are converting x to x bar for covariant formulation, then del xi is here, del x bar z is here, but most importantly these two powers are in the below portion. So you can easily understand the contravariant and covariant tensor by observing its index and its component formulation. So this is rank 1 tensor and rank 2 tensor both. So that's for now today. After my next video, I will discuss in more detail about tensor. Thank you.